In this video lesson, we're going to be taking a look at application problems that involve one-step linear equations. At this point, you should be familiar with inverse operations and solving one-step linear equations. For the application problems we're solving, we will be following the five-step procedure listed here. The first step is define a variable. Typically, that'll be the letter x, but it can be any letter you want. And your variable needs to represent the unknown quantity in the problem. Once you've defined a variable, then you need to translate the words of the problem using numbers, variables, and mathematical symbols into an equation. And once you've got your equation, you can solve it, check your solution, and finally write your answer as a statement. So let's look at our first practice problem. This year, a teacher graded 58 fewer final exams than last year. If the teacher graded 467 final exams this year, how many final exams did the teacher grade last year? The first step in this process is to define a variable. We're going to be using the letter x in the problem, so let's go ahead and define that at this time. The letter x needs to represent the unknown quantity for this problem. The unknown quantity, that is the amount we're trying to figure out, is how many final exams did the teacher grade last year? All right, now that we've defined our variable, it's time for us to write an equation that matches this problem. So let's write our equation now. We're going to be using the first sentence to help us with our equation. The first sentence says this year the teacher graded 58 fewer exams than last year. We know that the teacher graded 467 final exams this year. So that's how we can start our equation. All right. For the second part of the equation, we're going to look at this phrase here. The teacher graded 58 fewer final exams than last year. Mathematically, fewer indicates less than. So we need an expression for 58 less than x. And now we have an equation that represents the problem. 467 equals x minus 58. So now it's time for us to solve this equation. In order to get x by itself, we're going to add 58 on both sides of our equation, like this. And when we do that, we end up with a solution of 525. Now that we have a solution, it's time for us to check that solution. So we're going to write our original equation down. 467 equals, we'll go ahead and replace x with 525 and do the math. Turns out 525 minus 58 really does make 467, so we feel good about our answer. And it's time to move on to step 5, which is to write out our answer as a statement matching the question that was asked. So the question was, how many final exams did the teacher grade last year? The answer is the teacher graded 525 final exams last year. Let's go ahead and move on to our next problem. A rectangle is 6.85 meters wide and has an area of 90.42 square meters. What is the length of the rectangle? Once again, we need to define a variable. The unknown quantity, the length of the rectangle, is going to be represented by the variable. In this problem, let's go ahead and use the letter L to represent the length of the rectangle. There we go. Now it's time for step 2, which is to write an equation matching the problem. So let's go ahead and do that now. In order to write an equation for this problem, you have to know that area for a rectangle is found by multiplying the length times the width. So when it says the area is 90.42, that means the length times the width is 90.42. Now in order to write length times width equals 90.42, I'll use my variable for length. I'll use 6.85 for the width, and of course that's equal to 90.42. And now it's time to solve our equation. In order to solve this, we're going to divide both sides by 6.85. And of course the math involved is easily done on a calculator. So if you take 90.42 divided by 6.85, we end up with 13.2. At this point, we're going to check our answer. Let's go ahead and take 13.2 and plug it in for L in the original equation. And that's going to look like this. 13.2 times 6.85 equals 90.42. And again, with the help of a calculator, we realize that 13.2 times 6.85 really does equal 90.42. So our answer works. It makes sense within the context of the problem. And now it's time to write our final answer as a sentence. There we go. The rectangle has a length of 13.2 meters. Let's move on to our last problem. A statistician has conducted 180 surveys, and this is 5/9 of the total number of surveys that need to be conducted. What is the total number of surveys that need to be conducted? We're going to define our variable. For this problem, we're going to use x. And the unknown quantity in this problem is the number of surveys that need to be conducted. Now that we have our variable, it's time to write an equation for this problem. We know that 180 surveys means equals 5/9 of the total number of surveys that need to be conducted. So to write our equation, we'll start with 180, and then there's the equal sign. 5/9 of means 5/9 times the number of surveys, and of course we don't know what that number is, so we'll put x there. So our equation is 180 equals 5/9 x. Let's go ahead and solve this equation now. In order to get x by itself, we need to divide both sides by 5/9. But when dividing a fraction, we actually do that by multiplying the reciprocal. So we're going to take the reciprocal, which is 9/5, and we're going to multiply that by both sides. There we go. And of course, on the right side, the letter x is left isolated. On the left side, we can reduce 5 and 180, and that's going to give us 36. There we go. And 9 times 36 gives us 324. So our solution is 324. Now it's time to check that solution. We're going to write our original equation. 180 equals 5/9. And instead of x, we're going to be multiplying 324. And 324 can reduce with 9 to make 36, and 5 times 36 really is 180. So it looks like our answer is correct. It makes sense within the context of the problem, and we can move on to writing out our final answer as a sentence. And there we have it. A total of 324 surveys need to be conducted. That concludes our video lesson on application problems involving one-step equations. I hope this has been helpful for you.